People are quick to point out problems. And when someone finally has a solution, they're even quicker to point out new problems. And when it's finally fixed and solved, and people are quick to, yeah, you get my point. Well, let's go solve some problems. We have one of the most advanced construction robots in the world sitting right here. It works perfectly in France. It's even revolutionizing construction across Europe and the Middle East. But we're not in Europe and we're not in the Middle East. We're in Canada. And it turns out teaching a French robot to build with Canadian materials is way harder than we could have guessed. All this started when I bought a 3D concrete printer. The goal was simple: print components for houses, or even full houses, faster, cheaper, better. But because this technology is brand new, at least here in Canada, we had to teach ourselves everything. Not just how to use the machine, but how to make 3D printable concrete. We spent months getting up to speed, finding partners, and launching our own training program, just to find people who could actually run this thing. And eventually, we got some good news. Hey, what's up, buddy?
Tell me you love me.
I do. I usually do, but wow, why are you in such a good mood?
You want the good news or the bad news?
Okay, give me the bad news first.
It's minus 20 outside and we're gonna get another 20 centimeters of snow today.
Yeah, that's not good.
Now the good news, we finally submitted for our wall certification.
What? Damn! What the hell, man? Seriously?
5 years, baby, hard work. Structural 3D printed wall approval. Any municipality in Ontario starting off, immediately approved. Let's go.
Boom! That's amazing.
So the really important thing to mention about the wall certification is what this does for us here in Ontario means that any project that we have or any of our partners or collaborators have, when we go for permit, we'll be able to show them our wall certification and we'll be immediately approved to use that system of building envelope right out of the gate.
And no one will be able to do this but us. That is the coolest part about this. We are finally certified for printing modular wall systems, possibly the first and only ones in Ontario.
Chris, viewers, as mentioned before, there are no standards for 3D printing, right? So we're
in all of Canada.
In the world.
In the world?
In the world, right? There are no standards. Everybody's working on standards, but there is nothing set by ASTM, CSA, anywhere in the world. What we've done last 5 years, all the research, all the testing that we've completed, comparing our wall, our structural 3D printed wall, to masonry construction, for example, that has codes. All that testing, we're done. We submitted a 900-page application for our wall certification. Upon review, we will get a seal for our wall assembly. So when we go to permit for 81 Aileen, 6 Nations, anywhere in Ontario to start, we are immediately approved for structural wall assembly.
That was a win, but the win, it quickly turned into worry.
Good news aside, bad news. So we do have some issues with the technology. The Maxi printer is not working right now. The material is an issue. Power to the site is also an issue. We got 3 problems we need to figure out. My guys have been trying to figure it out. You know, we have to get in touch with the manufacturer, the guys in France. They're gonna have to sort this situation out because we're not able to address the wobble.
We have a big problem. For some reason, the arm on our 3D printer was wobbling. And you can see it right here. The wobble is a huge issue because it directly affects the shape of our building. If what we're printing isn't perfectly accurate, it can lead to really big problems. Massive problem. We got to get the guy's arm from France.
Second issue, the material. The material we're using with MyPay, we were using Sika's material, which was no good. The MyPay material is better, but it's still not deployable today. 3D printing hasn't taken off in Canada. It's pumping in the US, it's all over Europe, it's going on in Asia, Canada. There's, you know, a handful of companies that are in this industry. So the material isn't honed in. We're not using the US version, we're not using the European version, we're using the Canadian made version. Now, with the pre-blended material from MyPay, with the Maxi printer, it's not dialed in.
Like, it's important to understand that when we talk about 3D printing, this is Lee Newman. He is the technical 3D printing guy in Canada. I am a builder who was using the product and working with him. So when we talk about 3D printing and technicalities, you're never gonna hear it from me. Because let's face it, I don't know enough. I'm like you, I bought it, now I'm using it. But obviously I'm not using it because we can't use it.
But we're gonna help them use it,
Yeah.
so we can all use it.
Exactly. This isn't a mechanical failure. It's actually a calibration issue. The machine is incredibly sensitive, and our local concrete mix is reacting differently than the French mix the machine is used to. This isn't even about fixing a broken machine. The machine's fine. It's about translation. We have to translate this proven European method into Canadian reality. We have different materials, we have different climates, we have different regulations. If we can't get the translation down, we can't even print houses. And people are waiting for those. Well, if it was easy, it would have been done already.
Good morning.
I commanded the team to get in touch with France to solve this issue. And yeah, they sent Thomas all the way from France to deal with me.
We got to figure out what the problems are today with the Maxi printer. We have issues with the ability to print. We have inconsistencies with it holding a lot of the material. We got a problem with its up and down, and there's a wobble in the arm. We can't have these types of issues. So what we've got right now is we've got the guys from Construction 3D, and they've flown in, and they're gonna try and help us out with this right now. So, hey, what's up, buddy? I need you to fix some huge problems right now.
I understand.
So I know you guys took some time and you tried to figure out some of the solutions to what we've got, but what's happening right now is I've got major events coming up. I've put together the industry for Canada on how 3D printing can be used. But more importantly though, you need to fix my fucking problem or else I'm gonna have a massive issue with me moving this forward.
I see.
All right, so let's go and I'll show you what's going on.
Let's go.
Thomas was not defensive. He was actually curious and really helpful. He collected tons of data to bring back to the engineers in France. This is what partnership looks like. They aren't leaving us just to figure it out alone. They're there step by step, hand in hand, ready to help us get through this. And later, of course, I had a few drinks with Thomas and he went back to Construction 3D HQ to work on a fix with the French team, while I started working on the other problems. We have contracts signed. We have the tool to do the job, but until we dial in the specific Canadian configurations, we are stuck in R&D mode while the clock is ticking.
It's one thing to, I guess, talk about building with different materials and building with technology, because it sounds fun and it sounds cool. But there's so much more to the development of using that technology and finding the right place for it, using it as the right tool. I think that's the part of what I've been trying to accomplish by working with my 3D printer. Now I got an amazing team that we've got working around us, Printera. These guys are fantastic. Construction 3D, amazing. Like that's just one aspect of 3D printing. But then there's the utilization of all of these different technologies into one solution, because I truly don't believe that it's just one thing. It's a combination of different materials and different components, different technologies, and different people's minds that are going to be able to come together to create amazing products. Is it going to be one multi-billion-dollar company that's going to come up with a solution, a modular facility or a factory? Maybe, but probably not. It'll be a combination of all of the people from around the world that have different solutions to their environment and to their ability to produce a product that works for where they live and the best product for that end result. It's going to create new jobs. It's going to create new industry. It's going to create everything that will lead us to a different future. And it's a massive change. It is a revolution, a real revolution. Antoine Mott said it the best. It is a real revolution. And with revolution, there's a lot of change. Whether that's negative or positive, well, I guess that's what's going to come. And hopefully this show documents all of those aspects. Now, I know this was a massive rant, but Brandon told me this is what I had to do. And so this is what I've done.
I set out to learn about our materials problem. We have to fix what goes inside the arm. If I understand it, I can find a solution. In order for us to understand mixes better, we're gonna have to understand what goes into a mix. especially when it comes to concrete printing. Because, well, let's face it, I don't understand any of that stuff, but let's go see someone who actually does. I met with Carlos to get an understanding of 3D printable concrete. This man right over here, Mr. Carlos, he's gonna tell us everything we need to know about mixes. Obviously, this isn't just concrete. How can we fix this problem, and how are we gonna be able to be able to build these buildings that we have coming up without running into problems, especially in the field? I had no idea that concrete could actually be so complex. To 3D print a concrete wall, you need a very special kind of concrete. We start with fine sand, cement, a little bit of water, and some short fibers. These fibers act like tiny invisible threads that help the concrete stay mechanically strong and cohesive.
Typically in this mix, what you have is normal cement, coarse aggregate, which is really small. We have like 3 millimeters of aggregate, fine aggregate, which is like 1 millimeter, sand.
Yeah.
You also have fibers. We have polypropylene fibers in the mix. Basically what this does is that when we're mixing, the concrete gets really, really hot, right? So then, because the concrete gets hot and you have water in the mix, the water starts to evaporate.
Sometimes we need our concrete to harden faster, especially when printing in cool weather. We add accelerators such as calcium nitrate or triethanolamine. These chemicals introduce extra calcium ions or change the hydration chemistry, speeding up how quickly the cement and water form crystals. Because the mix is already low in water, the accelerator helps the walls gain strength within hours. On extremely hot days, our mix can set too quickly. To prevent this, we add a small amount of a retarder. Natural compounds like sucrose, citric acid, or tartaric acid attach to the cement particles, slowing the reaction just enough to avoid cracking. Another retarder, sodium gluconate, is derived from glucose. We use these sparingly.
And you don't want those, like when the water starts to evaporate, it creates cracks. In order to prevent to have those cracks, we use those polypropylene fibers, and you can see it here. If you get closer to these cracks,
Yep.
you can see how they start to
Yeah,
form.
I can see it.
But then the fibers, it's perfectly showing in there how when the crack happens, the fibers start to pull the concrete back again together, right?
Together, like so it binds
Correct. Correct.
Got it.
So we don't know exactly what type of plasticizer, what type of fine aggregate, coarse aggregate it's in the mix, because that's proprietary mix of MAPE and Sika and all these manufacturers. But we kind of know how it works, right?
Our first helper is the super plasticizer. Scientists make it by linking acrylic acid and polyethylene glycol to create long comb-shaped molecules called polycarboxylate ethers. These combs wrap around cement grains. Their side chains spread out like arms, pushing other grains away so the mixture flows smoothly even though we use very little water.
It's that in 3DCP, there's two different types of pumps, especially two different types of nozzles, right? So for example, over here, we have what is the MTech pump, right? Basically what this does is you receive a commercial mix, like you said, MAPE, Sika, and you just add water to the mix. So this is called 1K system because it's only one component, K from component in German.
There are mainly two different types of printers, a 1K printer and a 2K printer. A 1K printer uses one complete concrete mix. Everything cement, sand, fibers, chemicals is mixed together before pumping. The mix must be perfectly balanced, pumpable, printable, and able to harden at the right speed. Whereas a 2K printer uses two materials. The main concrete mix is pumped first. A second line delivers a chemical activator, usually an accelerator. These two materials only meet right at the nozzle. Why this matters? Well, this gives engineers much more control. The concrete stays workable in the hose and then hardens instantly when printed.
The main issue that we have with this type of equipment is that we don't have that accelerator and that stiffener that can help us keep the mix in place, right? So however the mix is coming from the batch is however we're printing that mix. It's a trial and error type of situation at the beginning, but once you get all the data in terms of what's the perfect temperature to start printing and the perfect pressure, that's completely.
And that's why we're testing
Correct.
so many different walls and spending all this money to get there.
Correct.
And
then the beauty that you have by doing this thing is that you can create a data sheet where you basically say, you know what? We have already printed in the past 25 degrees. So you already know how much water and what temperature of water you need in your material to be able to print completely fine at those conditions.
Because you've already built the data that's going to be able to give you the exact parameters for that print using that material within those conditions.
Correct.
Wow, it's very scientific. Man, there are so many variables. I can easily see how this machine is struggling using something it wasn't even intended for.
The material in this print, it's perfect. As you can see, you can come closer. The material was bonding between layers. There's no cracks of plastic shrinkage. Plastic shrinkage is the evaporation of the material at early stages. The problem with this thing was the G code that was programmed for this thing wasn't optimum. It was stopping really early and starting again really early. That's why you have like these big voids in here.
We showed that. We showed that in the last video when we described 3D printing and how it has to actually line up. And if there's stops that are between on the drawings, if they don't go all the way, they lead to this. France was working away, smoothing things out with the arm. And so were my guys.
That's a coding issue. Then as you can see, all these little like bumps in the layers is just because of the nozzle. Like we were trying different types of nozzles, 3D printed.
3D printed nozzle?
It's a 3D printed nozzle, indeed.
And you guys came up with this?
Nick over there.
Nick did. Oh, wow, Nick.
Yeah.
Well, this is cool, man. I never actually got to see it. This is Nick and Fola. Remember that course I told you about earlier? These guys are teaching it. They were actually students at one point, and now they've come to me with a possible solution. They designed a 3D printed nozzle for the 3D printer. It's kind of funny when you think about it. Well, it seems to kind of be helping. And will that give us the ability to print smoother?
So if we can extend this thing a little bit more, we can get rid of these small lines over here, right?
This is what we're making, is like we're creating the tools we need now. Like we don't know what we need. Every time we make a new head or do something new, we have to invent it again and again and again. And we have to do it like day by day, week by week, that we don't know the problems. We're learning them now as we go and then come up with a new solution and keep going.
Problems don't always mean that something is a failure or is never going to work. Sometimes it just means that we have to change how we're going about it. We went into this approaching it like a one-size-fits-all solution. That the tools and the people would seamlessly integrate and just, well, work. But this isn't anything like that. It's so much bigger. We're creating a new system of building in a place that not only hasn't seen anything like it before, but isn't even sure if it wants it. This involves new tools, yes, but it also involves updating our entire system and the way that we build. The rules, the regulations, and the mindsets of the people dictating what can and can't be done. We could have looked at the wobble and said, this machine doesn't even work, but that's the amateur mindset. The disruptor mindset? Well, that's realizing that innovation is a two-way street. We had to learn the machine, and the machine had to learn our environment. A revolution doesn't happen alone. It happens when manufacturers, engineers, and builders come together to solve the hard problems. France is helping us with the software. We're creating material that is designed for this application, and our team is already designing the next version of Nozzle to help make 3D printing work in a wider range of use cases. This is how we do this, together. We're tackling problems head on, and with your help, we will get this in front of the right people. So, like, subscribe, and share this with anyone you think can be part of our solution. Because if it was easy, it would have been done already. Now, let's build some houses.